In question 2, we got a figure that shows a block of mass m resting on a 20-degree slope. Then the block has coefficients of friction m sub s equal to 0.64 and u sub k equal to 0.54 with the surface. Now it says that it's connected via a massless string over a massless frictionless pulley to a hanging block of mass 2 kilograms. They're asking what is the minimum mass m that will stick and not slip. So I drew already a representation of the question, and over here we can notice that the acceleration is going to be 0. Right here is frictionless, but in this case there is a friction. There's a static friction. Now we're going to separate these things in the y prime direction and on the x prime direction. So regarding the mass, there's a weight going down, and if we look at that y prime direction, this side below the mass or next to the weight is going to be mg cosine of theta. It's going to be useful for later. Right over here we got the friction that we're going to use, and that's going to be the static force. Static friction 0.64. Now regarding the y direction, the sum of the forces goes as follows. Here's the mass, and there's a normal force going upwards, and the force going downwards is going to be the weight times the cosine of theta, so mg cosine of theta. So the sum of all the forces in the x prime direction is going to be t minus mg sine of theta minus m sub s times the normal force being equal to 0. In the y prime direction, we got mg cosine of theta minus the normal force being equal to 0, and that is because the acceleration will be 0. Now at the bottom of the string right here, we got a mass 2 kilos. So we're gonna do the forces in that case. We got the tension going upwards and the weight going downwards. Moreover, the acceleration will be 0, so t minus mg equals 0, or t minus 2g, because the mass is 2, equal to 0. So that will give us a tension of 20 newtons. Now to find little m, the mass in the middle, we're going to use the formula t minus mg sine of theta minus m sub s times mg cosine of theta, which in this case is the normal force, equal to 0, and that's representing the sum of all the forces in the x direction, equal to 0. So as we do that, we give each of one of the mass, the normal force, the m sub s, we give those values, and now we're going to try to solve for little m. So that should give us a value of 2.1 kilograms.